squared plus 4x and multiplied by 7 the square root of x plus 1. Good. So this is the product rule. Always, like with limits, if you remember, we said we always have to plug it in. Always have to plug it in to see what is. I would say I take that back. 99% of the situation. Sometimes we have to do some work before we plug it in. But the starting point, regardless, the starting point has to be this. The same thing here. When I look at the function, I assess what type of function I'm looking at. That's my first step. And I realize this is a product. So it's a product of two functions. You can say, I want to distribute. Fine, you can. But if you want to illustrate or if you want to practice the product rule, then you have to write, so 1 times 2 prime equals 1 prime times 2 plus 1 times 2 prime. Again, this is my style. You develop your own. I prefer 1, 2, 1, 2, 1, 2. But you can say, no, I have a different sequence. Fine. I'm okay with that. Okay, so f prime of x. First, I have to differentiate the first part, for the first function, 6x plus 4. I have to copy the second function, 7 the square root of x plus 1, plus I copy now the first function, and I multiply by this differentiated. And if you remember, we know the rule that the square root of x prime is 1 over 2 the square root of x. And I just have to have a 7 at the top, and that's it. Because 1 prime is 0. So I'm happy with this, because this function is quite ugly, I would say. I'm happy with this. If you keep it as is, that's fine. You can simplify it. You can try to simplify it if you want. It's not going to be pretty. So that's why I'm saying I'm happy with this. If you took it further, I'm happy with that too. If you left it as is, I'm happy with that as well. Is this good enough? Is this okay?
Yes, thank you.
Perfect. Anything else? Are there other questions? Anything else you want us to work on? Anything else? Justin, you had something? I thought you may have had something.
No, I was just tracing
Okay. Okay. Perfect. Anybody else? Okay. So in that case, if you remember, I have some leftovers, meaning going back to applications. We did not get the chance. I wanted to finish up and have all the different rules. I wasn't able to. So now I'm going to go back and select a problem from the power rule, an application, sum or difference, product, quotient, and then finish up with a chain rule. Okay. So where am I? I'm on page, yes, I'm on page 155. Okay. If you remember something else that you want to ask, you can always stop me, please. I just wanted to illustrate why we need to know how to differentiate sum and differences and powers. So here's an example. Growth of a child. The median weight of a boy whose age is between 0 and 36 months is approximately given by W of t, and this is problem 87, and the page is 155. So we have W of t, 8.15 plus 1.82 t minus 0.0596 t squared plus 0.000758 t to the third. And the function is also pictured here for us. Okay, age in months on the x-axis and the median weight in pounds. Let's see what they want. The rate of change of weight with respect to time. Can anyone tell us what we need to do to determine the rate of change of weight with respect to time? What do you think we have to determine?
The difference quotient?
You mean the limit of the difference quotient?
Yes,
Yeah.
or rate of change. Or,
So in other words, W prime. This is the rate of change. And it has to have two measurement units. Please remember, if I ask you what was your speed yesterday going through, I don't know, Ritchie Highway, you cannot say 20 miles. You have to say 20 miles an hour, or 40 or 50 or whatever it was. So please remember, the rate of change is a ratio of two variables. Which variables? Y variable at the top and the X variable at the bottom. So that's why the answer is always going to have the two measurement units. Good. So this is a piece of cake. We know how to differentiate this, but I'm going to put it in the correct order. So I have to bring down 3, multiply this thing by 3, and then get t squared. So correct me if I'm wrong. 7 and 1, 22. So now 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Good. Now I'm here. Minus t. So now I multiply this by 2. 2 and 1, 18, 9 and 1, 10, 12. 1, 2, 3, 4. 1, 2, 3, 4. And finally plus 1.82. So when we're asked to find the rate of change of a function, in this case, the rate of change of weight, which is in pounds, with respect to t, which is in months, the answer, whatever, when we evaluate it, has to be in pounds per month, carved in stone. So this was part A. Any questions, anybody? Please. Okay. Part B, the weight of a boy at age 10 months. Okay. Can anyone tell us how we determine the weight of a boy at 10 months? What do you think? How do we determine that?
Into the W prime plug in 10 for T.
It says the weight. It doesn't say the rate of change at 10 months. And thank you for making that mistake, because it's very important to emphasize that. Thank you. I'm not kidding. I really needed to discuss that. So when I'm asked to find the weight, so if you ask me where I am, I'm going to say 25 miles from Arnold, as an example. But when you ask me, what is your speed in when you drive, I'm going to say at 25 miles an hour. And that is the rate of change of distance with respect to time from Arnold. So let me just change the camera for a second. So when I'm asked to find the rate of change at 10 months, I have to evaluate the derivative. But if I'm asked, find the weight at 10 months, I have to use the function weight of time. Do you see the difference between these two? Yes? So when I find the weight, I'm telling you my weight is 100, or the boy's weight is 50. But if you ask me how fast is the weight of the boy changing in 10 months, then I will say how fast. I will say at 1 pound per month. Do you see the difference between W and W prime? Any sign? Anything? Is that a yes? Is that a no? Maybe? Is anyone with me?
I'm following.
Okay. Anybody else is following? Everybody? Yes? Okay. Good. So in this case, actually, I just want to share my screen. In this case, I'm going to go to the calculator. My calculator has just disappeared in thin air. Okay, here it is. So, because the next question here, what did I just do? So the next question is the rate of change of a boy's weight with respect to time at age 10. So this one is asking me to find W of 10, and this one is asking me what? Part C.
W prime.
W prime of 10. The first one will be in pounds, and the second one will be in pounds per month. See the difference between the two functions and the two measurement units? Why is, okay. Good, so we are going to enter two functions. I'm going to enter W, which is 8.15 plus 1.82 x minus 0.0596 t squared and a plus 0.30758 t to the third. And now I'm going to enter the derivative, and the derivative is 0.002274 t squared, and then minus 0.1292 t, and then plus 1.82. So now when I go to second table and I enter 10, this is the weight at 10 months, and this is how fast the weight is changing precisely at 10 months, the instantaneous rate of change. So at 10 months, the weight of the boy is 21.15 pounds. Let me write that down. 21.15. At that particular instant, his weight is changing at 0.76 pounds per month. Again, is this clear? Yes or no? Yes? No? Okay. So let's go back and look at another problem. For example, the heart rate. We're given an expression, which is a function, can be used to determine the heart rate R of a person whose heart pumps 6,000 milliliters of blood per minute, and V milliliters of blood per beat. So it's a little bit confusing. This is the output per beat, and this is the heart rate in beats per minute. So careful. Careful because of the measurement unit. The measurement unit of R is beats per minute. But can anyone tell us what is the measurement unit for R prime? Can anyone give us the measurement unit for R prime, please?
Is it 1?
Measurement unit. Measurement unit. So R of V equals 6,000 over V. You see here, it says heart rate. That's R. It's measured in beats per minute. But I'm asking, what is R prime measured in? Can anyone help with that? What is the measurement unit for R prime? So it means that it wasn't clear what I said before. So let's go back to the previous problem. We said that the measurement unit for W is pounds. What did we say that the measurement unit for W prime was? Anyone can help?
Was it
Anyone?
on pounds per month?
Of course. It's the rate of change. Thank you. It's the rate of change, right? It's the y variable, the measurement from the y variable over the measurement from the x variable. Good. Now let's establish here what is r prime measured in. So r is very clear. This is r of v. So it's in beats per minute. But I want to establish the measurement unit for r prime, please. What will be the measurement unit for r prime? So r prime is measured in what? Anybody, give it a try, please. Anyone would like to try? Anybody, please, let's not waste time.
Minutes to milliliters.
So first I have to have the y variable first in beats per minute. The y variable measurement from the y variable over the measurement from the x variable. So let's try one more time. It will be measured in anyone can help? And I'll write it
Is
down.
it
Yes?
the beats per minute
Yes?
over milliliters?
Yes, 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 over milliliters. Beats per minute over milliliters, because this is the measurement unit for y and this is the measurement unit for x. The measurement unit for y over the measurement unit for x. Find the rate of change with respect to v, and then find the heart rate at v, not the rate of change. Find the heart rate at v equals 80 milliliters per beat, and find the rate of change at v. So first, I will change this function conveniently. How will you change this function conveniently so you can differentiate? How would you change this? Make it easier to differentiate. What do we always do with a fraction like this? With a number over the variable. Is there a way of rewriting 1 over the variable somehow? So 6,000 times what? Is there an exponential notation that allows us to write 1 over v in a different way?
Is it v to the negative 1,000?
Thank you very much. This is much easier to differentiate than this, especially because the numerator doesn't even have the variable. Excellent. So thank you, George. So r prime of v is bring down the power and subtract 1 from the power. And now we're asked to determine r of 80, r of 80 and r prime of 80. So r of 80 and r prime of 80. These will have two different measurement units. This one has beats per minute, but this one has beats per minute per milliliter. So please understand the difference. So of course I'm going to plug them in the graphing calculator, both at the same time. Clear, Clear, go back up. So the first one is, you can write it as 6,000 over V, which is X in the calculator. And the other one is negative 6,000 divided by V squared. And now what I have to do is just plug in 80. Do not calculate these by hand. Please enter them in the graphing calculator. So the first one is 75, and the other one is negative 0.94. Again, can anyone give us the measurement units for these two? For 75 and for negative 0.94. Anybody? Please. They're right there on the paper. For this one, we have what? For R of 80, what is the measurement unit? And what is the measurement unit for R prime?
For the first one, beats per minute,
Yes, beats per minute, of course.
and the second one, beats per minute per milliliter.
That's it. Thank you very much. Exactly. Excellent. Good. Thank you. Thank you. Thank you. Okay. We're moving on to the product and the quotient.